All right, so now that you know how to summarize and visualize the simple linear regression, let's talk about actually being able to analyze this data. So if we want to run the model, okay, we're going to run this line here, right? So I'm going to explain, you always have to run library stack poly package. And let's do that to get access to our data set. Again, we're using this function called LM, and LM stands for linear model. And so it's kind of similar to the AOV function for ANOVA, where your response variable is going to come first, and it's going to be followed by a tilde, then your explanatory variable. So your explanatory variable is trying to explain the variability in your response, okay? And you're going to use LM, linear model, for that. And you're going to say data, comma data is equal to King County data. And so you have to save whatever function that you have into some type of label. So we do that. So it's model SLR or model 1 SLR. It doesn't matter the name. You can name it whatever you want to. I'm just going to run it as, or at least save it as model 1 SLR. Okay, great. And ran. And so the biggest kicker here is to be able to visualize or at least see the actual report of the regression model. Okay, so I'm going to highlight a couple things once I run this. So you run summary model 1 underscore SLR. Okay, so the first thing that it provides for you is just the function that you already just ran. Great, fantastic. The next thing that's really the first thing that's important, it gives you the residuals. It gives you the 5-number summary of your residuals for every single data point. So it gives you your min value for your residual, and it gives you your max value for your residual. It gives you your median for your residual, your first quartile, and your third quartile. Great, fantastic. One of the most important things of this output is going to be your coefficients. So this is going, where it says estimate, that provides you with your coefficient for your y-intercept. This particular value, 1.627 times 10 to the 1 power. Okay, that's going to give you your y-intercept. Whereas when it says estimate for BWT, that's going to give you your slope. It's going to give you your slope. Your standard error. This stands for standard error. It's your standard error for your y-intercept. This value here. This value here. And it's your standard error. And this is your standard error for birth weight. Okay, the slope. And then this next column provides you with your test statistic. Okay. Little fun fact, all these estimates follow a t-distribution. And so this is your test statistic for the y-intercept, and this is your test statistic for your slope, your birth weight, okay? And then finally, it gives you your p-values. So you can see that these p-values are very, very small, very small. What's important here is that this is your standard deviation of your residuals, okay? In R, they call it the residual standard error, but this is called your standard deviation of your residuals. This provides you the degrees of freedom for your test. In terms of simple linear regression, we're only going to highlight this actual feature here, and this is your R squared. I know it says multiple R squared, but in terms of how R spits out our numbers, this is going to be our R squared value, okay? The other pieces of information, I will highlight that in multiple linear regression, but in terms of regression, this is our R squared. This is the standard deviation of the residuals, okay? And then this talks about the actual regression line, and then this provides information about your residuals or your error, okay? At least your 5-number summary for your error. All right, so from there, what we can then do is visualize the assumptions for the regression model that we ran. So if you type plot model SLR, you'll see the screen. And if you press return or enter, you can see the residual versus fitted. Okay, great. If you press enter again, you see the QQ plot of your residuals. Press enter again. This will allow you to see your fitted values against your standardized residuals. And then if you hit it again, it'll allow you to see the leverage points versus your standardized residuals. Okay, so that is that. Last but not least is to be able to talk about, or at least run prediction intervals. So I'm going to copy and paste this code. Okay, so in terms of prediction intervals, what happens here is that you're trying to predict a value. Okay, what's going to happen if my birth rate is 2,500? What's going to be the average gain weight? What's going to be the average gain weight? So when I'm talking about the average gain weight in terms of 2,500, I can consider a prediction interval when I'm really just specifying one value. I'm specifying one value. So here, what's important to note is that you're utilizing this function called predict. You have to provide it first, the model that you're running. Then the new observation is called new data is equal to this new observation that you've created. So this BW2 is your explanatory variable, and you're setting equal to 2,500, and that's the format you have to keep. So it's the explanatory variable from here, and you're setting equal to some specified value, and then you just run accordingly. You say your interval is prediction, and the level is 0.95, so it's a 95% confidence interval that is going to be created. So when I run this, sorry, I ran. See, mistakes can happen. So I need to run this line first, and then this line. Okay. So if I were to plug 2,500 into this original regression model, right? If I plug 2,500 into the original regression model, my fit would be 27.99. Okay, that'll be just a fit. However, in terms of a 95% confidence interval for a particular value, okay, with an individual that the baby weighs 2,500, the weight gain is going to be in between 2.18 and 53.8. Okay, so that's important to see. The next thing that you can do is create a prediction interval, right? Instead of creating a prediction interval, is to create a confidence interval. So we just say confidence. Again, spelling does matter. So confidence interval, again, is the average. What's the average value, okay? It allows you to find, make a prediction of the average value, but it also allows you to find a 95% confidence interval rather than a prediction interval, okay? And so you can see here, this is now our new interval. It's in between 27 and 28. Okay. So again, emphasizing the difference here. One's a confidence interval, confidence mean interval, and then this is just the prediction interval. Okay. Well, have fun with your practice.